Hello and welcome to our Foundry virtual events. My name is Jen Goldfinch. I'm the Director of Field Marketing at Foundry, and I'm really excited to be listening to today's session. Matt Mazerl, my colleague, our Director of Product New Technology, will be co-hosting the webinar, and along with our fabulous guest speaker, Bernhard Kimbacher, who's going to be speaking about his experience for using Nuke in the cloud. We'll have a live presentation, not recorded. So Bernie's doing this live, and we'll have time for Q&A after. We have 60 minutes set up for this webinar, but if the Q&A needs a little bit more time, we're here to hang out, so we'll go a bit longer. All right, enough with marketing. I'm not going to talk too much. What I did want to say, though, is I wanted to thank all the customers who have presented on our virtual events campaign over the last 3 months. We started this right when COVID started, end of March, and we've had amazing presenters from all over the world. So just a nod to our fantastic customers out there who've supported our initiatives. We've done 22, as I mentioned. All of these webinars are available on demand. You can go to foundry.com/events. My colleague Emma is going to pop in the link, and you could register for anything that you missed and also what's coming up. So we have a couple of things going on next week. Frank, hi. Sorry, I gotta get distracted from the chat. We're participating in the Lenovo event, so you're all welcome to join us there. We'll be doing a Nuke class, master class during that event, and we also have our own Foundry Live coming up starting on July 16th. So we have 4 sessions that we're going to be doing, which is going to feature product news, product updates, a product launch with Nuke 12.2, and all kinds of goodness. So please make sure you join our Foundry Live. Do you want to keep up to date with everything we have going on? We have a quarterly newsletter for Nuke and the Look Dev and Lighting tools. Also our Insights Hub. You can sign up for the ones you're interested in. And if you follow us on social, that's where we share a lot of our customer activity, our activities, as well as our partner work. We've got some great new content on our Insights Hub on Foundry.com. So we've got this really cool article about remote working in cloud, which might be interesting to some folks here. We also have some new training, and then there's been some great community resources that I've seen recently. Some great courses. So FX PhD just released a brand new training from Victor Perez. It's fantastic. I highly encourage you to take that out. And we have a couple of new courses as well from some of our community out there, like Ben McEwen and Josh Parks. So please check them out. Foundry's hiring, so if anyone is looking for work, we have a couple of positions open. Take a look at our careers page. If you think it fits your skill set, we'd love to hear from you and love to have you join our team and maybe host a webinar with us. And also, if anyone out there wants to help test the latest features of Nuke for our private beta groups, we are doing a call for beta users, so you'll see the criteria there. You can apply on the Nuke beta page as well. I just wanted to do a quick shout out and thank you to, of course, Bernhard from Hive and our friends at AWS and Teradici. We've been working together to make sure that our collaboration will help our users out there. So we've done quite a bit of testing. Teradici's done a lot of work on the testing. AWS has been super supportive. So I just want to give a shout out to them and thank them. So don't forget, during Foundry Live, for all you Nuke fans out there, we've got a special Nuke 12.2 release and announcement, and we're looking forward to seeing you on that webinar in 10 days from now. Foundry Live starts on July 16th. With that, I'm going to get off stage and introduce Matt Mazerl, my colleague. Welcome, Matt.
Hi, everyone. I'm really excited for this webinar. I'm so pleased to see so many people watching this, and I hope if you're watching it offline, you enjoy it as well. What I find especially exciting about this webinar is Bernhard has worked with Foundry in the past when he made use of Ethera, which was our cloud product that we discontinued last year. And what's really great is Bernhard's continued his journey into the cloud by evolving his studio on AWS. And I think what's really unique is how Bernie's going to share a lot of his tips and tricks and all the knowledge that he's gained about how to set stuff up in the cloud to make a really effective pipeline. So I'm really, really pleased that so many people are here to share in that knowledge. And I'll be in the chat answering questions. If you have any questions, just fire away. We'll do our best. And Bernard's also going to answer any questions that we're not able to respond to immediately at certain points during the presentation. So without further ado, let's check it out. It's going to be a very technical, very in-depth webinar, and let's get started.
Hello, everybody, and thanks for signing up. I can see we got just closing in on 100 people, so that's really good to see, and a lot of familiar names. That's great. So I got a bunch of content to cover, so I'm gonna keep the intro really brief. I just wanna, just very briefly introduce myself. My name is Bernie Kimbacher. I've been working in visual effects in Vancouver for about 15 years now. And during the time, I've always liked being involved in building pipelines and improving them and that sort of stuff. And about 5 years ago, as Matt mentioned, we started working together with Athera and actually used that for one production project too, which worked really well. And then, so that was in 2019 when I started HiVFX. And now in about October, I switched over to AWS and spent the last, what has it been, about 8 months probably, just developing that and diving into it and see what AWS can do. And it turns out it can do a lot. So that's what I want to show you today, how far I've come so far. And with that, I'm just going to start sharing my screen because everything is going to be live, of course, which is a little intimidating, but we'll see how it goes. All right. Everybody can see that? Matt, does that look good on your end? Okay, good. So I want to start with a brief overview of what we're going to cover today. So I'm going to start off with some AWS fundamentals. This is just a very brief intro to basic security things and budgets and things like that. So this is by no means an exhaustive list of how to properly secure your production environment, but this is just a bit of a primer on if you want to play around, just a few steps to take care of. We are then going to jump into actually building a workstation from scratch along with an FSX Lustre file system. That'll take about 20 minutes. After that, I'm going to jump over to a different environment and show you an environment that's a bit closer to my production environment, where we're going to look at what the FSX file system is actually capable of doing in terms of speed. And we're also going to look at deadline rendering. After that, I want to talk a bit, I'm going to go back to this presentation and I'm going to talk a bit more about theory, about how my production environment is set up and how cloud concepts are just a little bit different than your on-prem workflow might be. And finally, if we have time, hopefully we will jump over and do some Q&A. So with that being said, I'm going to come over here to my AWS console. I'm not going to be spending too much time about the console itself. The only thing I'm going to mention is you'll see these links up here. I'm going to jump around a lot between different AWS services up here. You can create these links by simply clicking on this pin, and then you can just drag any service. And there's obviously a lot in AWS, but the ones you use a lot, you can just drag up here. So the first thing I want to talk about is IAM, which is your identity and access management. So this is your basic user security. And you can see I got 4 exclamation marks here, meaning things are not set up right. So when you create your account, you want to make sure that you get check marks here. And if you just click this, it walks you through everything, how to set up MFA, how to create a separate user so you don't use your root user to do anything, and things like that. So do make sure you have 4 green check marks here before you do too much things in AWS. The next thing I want to talk about is budgets. I don't have a link up here, but if you want to go to any other service, of course, you can just look for it here. If I look for budgets, because it being a cloud environment, you can provision a lot of infrastructure very easily. So to make sure you're not getting a huge bill at the end of the month, it's a wise choice to create yourself a budget. And it's pretty easy. You can just make a cost budget. You can call it whatever you want, a monthly budget maybe. And maybe if you're just testing, you say, okay, I want to not spend more than $100 on this because I'm just playing around at this point. And then you can simply go, okay, maybe send me an email if I hit 80% of that actual cost. And you can just put in the email here, and then you have your budget created. So I highly recommend doing that. The next thing we're going to talk about, I'm going to jump back to the EC2 console, which is essentially all the compute services within AWS. And new accounts in AWS have limits, and those are there, of course, to protect you, so you don't provision too much while you're still new to AWS. And one important limit, if you want to play around with Teradata workstations, is that they use what's called the G4 instances, which is the GPU-based instances. So if you go on the last page in your limits, you see I have 32 virtual CPUs as my limit in this demo account. New accounts will have 0. So all you need to do, select this and request a limit increase. And AWS is usually very quick in approving that, sometimes minutes, but usually very, very quick. And the last thing I quickly want to mention is the AWS Marketplace, because we use Marketplace AMIs, which is machine images. So we will use the Teradata Cloud Access software for CentOS 7. And we will, well, this is actually what the license server is based on. And if we click on the Cloud Access software and we look at the pricing model, if you want to just play around with it, it has a 50 cents per hour charge. I just want it to be. If you want to use it more, you may want to look at annual pricing. So this can add up too. So I just want to be aware of what I provision here today and what it actually costs. So there's two options. In my production environment, I actually have purchased Teradata licenses directly, and I use those on custom AMIs. So in my production environment, I actually don't use this pre-built machine, but my own custom one. So that's all I wanted to talk about account basics. Just going to jump over to the VPC service, which is essentially all your networking. And I just want to show you what you get in your brand new account by default, because maybe you've seen some AWS diagrams and it has a lot of stuff on it. I just want to show you that a lot of that stuff you get by default if you just want to play around with. So we have our default VPC, which is like your basic virtual private cloud, which contains essentially everything you provisioned. You also get subnets in each availability zone in your region. So in my case, I'm on the East Coast. So I have in US East 1, I have 6 subnets. You may have 3 or 4, but you'll have at least 3. And you also get things like route tables and internet gateways. And if you are not sure what these mean, that's okay, because you get them by default. So it's all set up, but this essentially makes sure your instances will have access to the internet. What you also get, and that's the last thing I want to show that's the default, is you get this security group, which is essentially your firewall. So you get your default security group pre-created, and you'll see in inbound rules, it allows all traffic from the default security group, so from itself. So this concept is important to understand, that everything you put inside the security group will be able to freely communicate. So in our case, we will put the license server in here, we will put the workstation here, and we will also put the FSx Lustre system in here. So all of these things can talk to each other. Of course, again, in a production environment, you might want to split this up a bit more into more granular access control. But for this demo, we're just going to put it all in the same security group, just because it's easier to manage. So with that, we can jump over to our compute console again. And you can see I already have a license server running here. And one of the concepts that we're going to keep coming back to in this webinar is how in the cloud, of course, you can have a stopped instance here, which means you're not paying for that compute. You're really just paying for the root volume that this is based on. So in this case, I have a volume here, and I'm only paying for this 15 gigabyte volume, which holds the OS and everything that's on it. But while it's in a stopped state, I'm not actually paying for this. So let's start by I'm going to boot up my license server. And I was considering going through how to build a license server in this webinar. It was just getting a little too long, so I've pre-built it here. The only two things I'm going to mention is if you want to create your own license server that serves floating licenses to your workstations, what you want to do is in network interfaces, you can just create an interface before you build your license server. And then you can send this MAC address to Foundry, to get your license made for this MAC address. And then make sure just to not delete this network interface. So you want to make sure you keep this around. Otherwise, you're going to have to get a new license from Foundry. So with that said, we can get going on building an environment. I'm just going to show you in the presentation here quickly what we are going to do in the next 15, 20 minutes.
Hey, Bernie, there's some comments in the chat about the resolution being a little bit hard to read without destabilizing the presentation. If there's anything you can do about that, I think it might help folks to read the fine print in the AWS console.
Oh, okay. Let me see if I can. Yeah, okay. I'm not sure how to really zoom in on the font here on the Mac, to be honest. Oh, there we go. I was just
it already looks at it better from.
Oh, okay, good. So, okay, so maybe this is better. It's a bit bigger now. And hopefully in the presentation here, it's big enough anyways. But essentially, in terms of storage, everything is based on S3 buckets. S3, of course, has this famous 11 nines of durability, and it's very low cost. So it's really good for long-term storage and very durable storage. This is where you want to keep your data around while you shut everything else down. But it's not something you can natively mount directly on your Linux workstation. So what you need for that is that's where we use the FSX Lustre file system. Now that is a POSIX compliant file system, meaning your Linux machines can mount it directly, and it can deliver 200 MB per second per terabyte you provision, meaning if you provision a 10 terabyte file system, you get 2000 megabyte. If you provision 100 terabyte, you get 20,000 megabyte per second. So it scales linear pretty much to infinity, I want to say. Of course, there's account limits again. I think at 1 petabyte, you might need to ask AWS to allow you more storage. And it's, of course, is very low latency. So it's very quick to access from your workstations. And then the FSX file system delivers all the data to all your workstations. So we're going to, of course, only build one today, but it can, of course, serve hundreds or even thousands of workstations if that would be needed. And I just also want to mention that these G4 instances also have a local NVMe disk, which is a very fast locally mounted disk, which is great for caching, like in Nuke for application caching. It's very good, but it is temporary, so to speak. So if you shut down your instance, all data on this disk is going to be lost. So you don't want to obviously store any data, and it's not shared across the network either. So this is just your caching disk essentially. So this is what we're going to attempt to build today. So let's just get going with a Teradici workstation. So in order to launch this, I'm just going to go launch instance. And I'm just going to look for Teradici here. And in the marketplace, you'll see several Teradici products. We want to have the cloud access software for CentOS 7. So I'm going to select that. And again, here, when you do this the first time, you're going to have to subscribe. I'm already subscribed, so I can just continue through that. And you will see most of the instances are grayed out because this is specifically made to use with the G4 instances. I'm going to pick the G4 for extra large. We're going to look at the instance sizes a little bit later as well. But for this, I'm just going to pick the 4 extra large. There's a lot of options you can do, but most of the defaults are usually fine for testing at least. The only thing I'm going to say, I'm going to put everything in my 1A subnet here, so everything is in the same data center essentially. And the rest I'm going to leave to the default. Storage, maybe give it a little bit more than 8 gigabytes on the boot drive. I'm going to give it 20 gigabytes. I'm going to delete this in termination because I don't need that disk to be around. And with, I think, pretty much all AWS products, default encryption is always a good thing. And here you can see this is your NVMe disk. So you get a 225 gigabyte on this instance type. On a higher one, you get, I think, 900 gigabyte. And you get that by default. And then you can add tags if you want. This is good for cost tracking maybe, or maybe if you want to code some stuff that automates things, you can tag your instances here to do all kinds of stuff. And then for security groups, we're gonna go with the default security group it wants to create for us. So I'm just gonna call this Teradici. The name is a little bit shorter here. And then you see it wants to create an SSH port, HTTPS, and then 2 ports that the Teradici client is actually using. One thing to watch out for is by default, this comes in as wide open. So anybody from the internet can use those ports. So I recommend you maybe change this to your IP here. So it's a little bit more secure. And we just have a review page. And with that, we can launch it, and we'll ask you to make a key pair. So you can either choose an existing one, or you can create a new pair. I'm going to make a new one here. We call it Foundry. I'm going to download the key pair. And with that downloaded, I can launch. And this is really all it takes to launch a Teradici Cloud Workstation. While this is booting up, we can look at setting up our FSX file system. So we need, as we saw in the slide, we need 2 components for that. First, we're going to need a S3 bucket. So I'm going to open that in a new tab here. And I don't have any buckets in my demo account here, so I'm going to make a new one. And I'm going to give it a name. And this name has to be globally unique. So nobody else on the planet can have this name for an S3 bucket. So I'm going to see if Hive Foundry demo is available. And it is. And you can leave most of these default. Versioning could be interesting things. I'm not going to get into it, but it is quite a cool option. And I'm just going to go with default encryption again. And then block all public access is on by default. And obviously for any kind of production workloads or in any kind of cloud studio workflow, you want to keep this on. And it's actually quite hard to publicly share an S3 bucket now. So the danger of accidentally doing that is next to nothing. And one extra thing you can do if you want to really make your account more secure, AWS also added this somewhat recently, where you can have an account-wide setting where you block all public access with this on. You can't even accidentally share a S3 bucket. So that's the bucket created. Now we can jump over to FSX and create our file system. So we're just going to go create file system. You can create one for a Windows file server, but in our case, we want to create a Lustre for Linux. And again, there's a bunch of options. I won't go into them in too much detail. I'm just going to go with a 1.2 terabyte Lustre, which is the smallest size. But for this demo, that's just fine. You can pick your throughput mode. I'm going to pick the highest. It doesn't really matter for this demo, but that's OK. And here's, again, our default VPC that we got by just creating an account. And I'm going to put this in my default security group. As I mentioned earlier, we're going to put everything in this one group so everything can talk to each other. And I'm going to also put it in the same availability zone. And the last thing we need to do here, we need to now hook it up to our S3 bucket we just created. So we're going to put this in here. So you have S3, Hive, Foundry, demo. And now when you export data back out from your Lustre file system to the S3 bucket, you can choose here how that happens. In my case, I want to use the same prefix, meaning it will overwrite the data that is being imported. But in our case, this is an empty bucket anyways, so nothing is there to be overwritten. And then we can just review, everything looks good. And this will start creating our file system. This takes about, I think, 8 to 10 minutes usually. So while this is creating, we're going to look at all the other stuff. I'm going to jump back to the EC2 console here. And here's our workstation. And you can see, I made it a bit bigger because I have to slide over here a bit. You can see my license server is in a default security group here. My workstation is only in that Teradici group we created, which allows access from my local computer to connect to it. So we need to also add our workstation to the default security group. So we can just right click it here. And under networking, we can change security groups, and we will just add it to the default security group as well. So with that done now, I can connect from my local computer, and these two can also talk to each other to exchange license information. With that done, I can just grab the public IP from a workstation, and we can SSH into it. I'm going to connect graphically with it later, but for now I'm just going to SSH to install some other things. So you can see here's your Foundry key that we created. One thing you need to do before you can use it, you need to actually lock down the permissions, otherwise the SSH client won't allow you. So it's a simple chmod 400 on our Foundry file. So now this is a read-only file. And with that, we can just go SSH-I. We're going to use our Foundry key. And then the default user is CentOS at our IP address. And I'm just going to confirm that I trust this host. And with that, we're logged into SSH by this. One thing we got to do on this workstation that you don't get by default, of course, is the Lustre clients. So if we just go, and I just want to show you how easy it is to kind of Google for how to do things in AWS, because I obviously do this all the time too. Oh, how do I install this client? So I didn't want to write it down. I actually wanted to show you how to do it sort of from scratch. So here we are under installing the Lustre client, and this is the instructions for the Amazon Linux 2. But in our case, we are on CentOS 7.7 and newer. So here it just gives you the commands line by line. So I'm not going to go too much into what each of these does, but essentially it's adding the keys into repositories so you can actually install the Lustre client. I'm just going to paste these in here one by one. And we don't care about a specific version, we just want to have the latest. And now we can actually install them. These take quite a while, probably like 2 or 3 minutes to install. So while we wait for that, we can jump back to our instances here. And when I select my workstation, you can see a usage tab down here. So this essentially tells you how to log into this, into the Teradata workstation. So first, it tells you where to download the software client. I already have that downloaded here. And then second, it says login with username and password, where username is CentOS, as we just saw, and the password is the instance ID. So to actually connect it in a graphical way, what I'm going to do, I'm going to copy the public IP here again. And in my Teradata client here, this is one we're going to use later on in the demo. But for now, I'm going to create a new connection. And you will get this pop-up, which at first looks kind of like, oh, it's insecure. What this means is that by default, because they can't provide you a publicly trusted certificate, so it uses what's called a self-signed certificate. So all of the data that's transmitted is still encrypted, of course, but it is just not a publicly signed or publicly trusted certificate. So you can, for testing purposes, you can safely ignore this. And then as a user, as we just saw, it CentOS, and for password, I will grab the instance ID here. And let's see if this works. So here you go. Now we're already logged in with a Teradata software client to our G4 instance in AWS in about, I don't know how long it was, I'm guessing 10 minutes. So that's not, it's not terrible, I guess. So now what we're going to do here, of course, first is install Nuke. So I'm just going to download this from the Foundry website. Firefox tends to take a while putting up the first time around. I'm just going to go download Foundry Nuke. And here I'm just going to have to log in. And we're going to download Nuke for Linux, and we're just going to get the latest one. And I'm just going to save this here. And while that is downloading, I'm going to bring up a terminal here, and I'm going to make a directory where I'm going to install this. I'm going to do sudo make dir. I'm going to install it in this directory opt here, and I'm going to call the folder Foundry. And I'm going to the downloads folder, and it's almost done downloading here. There it is. So with that done, I'm just going to extract this zip file. So I'm going to go tar extract zip file and the new file. And with that done, I can remove my target file here, and then I can move my Nuke installer to the directory just created. So apt Foundry, move this guy over here. And to install it, all you have to do is run sudo /nuke, and you can just add this accept Foundry EULA. So it just installs right away. And this is going to run now for a couple of minutes probably. And while it does that, we can jump back to our terminal. And oh, this actually failed. So I wonder if I just missed one of the commands. Maybe I didn't copy paste it properly. So let me try this again. That's just the nature of doing things live, I suppose, and not pre-recording it. And so it looks like this key is here. This all looks good to me. Let's try if we can see. We can install this now. Matt, while this is running, do we have any questions already that popped up so far?
Yeah, we have a couple. Matt can drag them on stage. Do you want to keep going, Bernie?
Yeah, we have a question of, is there a concept for utilizing system snapshots, clone machines rather than having to install a workstation from scratch?
Yes, absolutely. That's actually a very good question. So the way this works is you've seen when we went to the marketplace here, we just grabbed the Teradigi AMI. So you can just make an AMI yourself. Maybe the easiest way to show you, well, I can show you how this would look. So if you say you go through the process of installing the entire machine and you're happy with it, at that point, you want to stop it before you do that. But after you do it, you can just go image and create an image. And that will make an AMI for you. So you can see I don't have any AMIs owned by me. If I go to public images, you can see there's lots of AMIs. These are all the public images out there. So this is your Amazon Linuxes and all those. But you can, of course, make your own. And then from there, you can spawn as many workstations as you want. So in a production workflow, you set up your base image, and from there you start, and then you configure it as you need by a per user basis. Oh, here's one for you, Matt. Is Foundry offering on-demand licensing? That was kind of one reason why I didn't want to show setting up a license server, I guess, because there's so many different licensing models. Like you can use a node locked one, you can use a license server. But that's probably a question better answered by Matt later.
Yeah, I'll try to get to that one in the chat in just a second. I'm firing through a few others.
Yeah, but it looks like the Lustre client's now installed properly. I'm not sure what happened there before, but that's just how it goes, I think, with live demos. So now what we're going to do is, in order to mount our Lustre file system somewhere, we need to make a directory to mount it. So I'm going to go sudo, oops, that's wrong, sudo make dir, and I'm going to mount it to data under the root. And I'm also going to make this available to everybody so we can actually write as a regular user. And now we can jump back to our Lustre documentation. So on the next step, we see how to mount this on an EC2 instance. So we see first we need to make a directory. We just done this. And then to mount it, here's essentially a command. So I'm going to copy the first bit here up until where we need the file system DNS name. And copy that. And I'm going to paste that in here. And then I'm going to jump over to our FSX page, and we see it is now available. And if I click on it, I can see that DNS name is right here. So I'm just going to copy this. I'm going to paste this in here. And looking back to our docs, we need @TCP. I'm just going to type this in like this. So you know, @TCP : and then we need the mount name. So I'm going to back to here, and our mount name is right here. Grab this guy, put in my mount name, and then where we want to mount it to, so to data. And that looks like it worked, so we can just double check this by going. And here you can see this is our Lustre file system. It's got 1.1 terabyte, and it's mounted to data. So that all looks good. So with that done, now we have a file system mounted on a workstation. We can jump back to our Teradici workstation, and we can see Nuke installed. And now to install the license for Nuke, I usually just run it first as sudo on Linux. It's just it has access to install the license. And if you just try and run Nuke, you will see you get an error. And that is simply because the Teradici workstation is quite a minimal workstation, which is a good thing because you want it to be fairly lightweight. But it also means for whichever app you want to use, you may need to install extra libraries. So for Nuke, it's the slipglue library. For Maya, it's probably a bunch more because it just relies on so much more libraries. So all we're going to do here is sudo yamdish-y install, and we need this slipglue here. And with that installed, now if we run Nuke, we should be able to get here. And we can just install a license. We're going to use a license server, and we're going to connect to it by 4101 and now we need to, oops, wrong one. We want to grab our license server, and we want to grab the private IP address, which is down here. So you don't want to grab your public one because you won't have access to it. You only want to make your license server available from within your private network. So you're going to grab your private IP here. And we're going to paste this in here. And license updated, so that looks good. So I'm going to quit here, and I just start it as a regular user here. I'm going to nuke and nuke. And with that, we have Nuke running on a virtual workstation in the cloud. So aside from one little hiccup, that worked pretty well, I think. So all I want to do now before I'm going to jump into the next part of the demo is I'm just going to make a very simple checkerboard, and I'm going to write this out to our data here. And I'm just going to call this image. And I'm just going to write out maybe a couple of images here. And looks like I still have permission here, so let me fix that here. Guess that didn't take last time. So let me try this again. And now we can write data there. So now with that done, let's say this is our day's work that we did. We created 2 checkerboard images, so that's not bad. And let's say our day is done. So I'm gonna close Nuke, and I can really just shut down my workstation here. So I'm just gonna go like any regular workstation you would on-premise too. And it's just giving us a warning because we're SSH'd in, so we're gonna be kicked off as well. That's okay. And we're just gonna power it off. And you'll see your Teradici client tells you that it has been disconnected, of course. And we'll see here in a few seconds, we'll see that this guy is shutting down. But what I want to show you is that those two images we just created, if we look into our bucket here, it's empty still. So the data only lives on the FSX file system. So what we need to do is we need to actually push the data back to the repository for our long-term storage. So in order to do this, we want to go to our file system here and export data to repository. And by just going with the defaults here, it will create a new task here, which is a data repository task, and it's now gonna look at the file system, and any new data it finds there, it will push back to our S3 bucket. While it's doing that, there's one more thing I wanted to show you on the instance page here. So what you can do here, I'm actually gonna wait until this is fully stopped. But one cool thing, as I talked about earlier, when an instance is stopped, it essentially is detached from the storage, from the boot drive, so to speak. So the compute component and the storage component are completely separate. So what that means is you can shut down your instance and you can actually change the instance type on the fly. So now that it's stopped, you can see we've used 4 extra large, and I can show you here. This is our G4 instance types and the options you have. So it goes all the way from an extra large, which has 4 CPUs and 16 gigs of memory. It goes all the way up to a 16 extra large, which has 64 CPUs and 256 memory. And then you can even get into multi-GPU territory where you can go up to 96 CPUs and some pretty crazy stats. So all you need for that is once it's stopped, I can just go instance settings, and I can change the instance type, and I can go, I have a really hard shot that I need to comp, and it's just very high res, and I want to have an 8 extra large now for that shot. And just like that, I can just now boot it up again, and I'm going to be using an 8 extra large instead. So that's a pretty cool feature, I think, and I think not super well known. So let's see how our repository task is, and it should be done by now. So you can see it succeeded, and it wrote 2 files because we wrote 2 images. If you look into our bucket here, we now have 2 images here. So if we are done for the day, and only going to come back in maybe, I don't know, 14 hours maybe from now, you don't necessarily want to pay for this file system to hang around doing nothing for you. So because you have it written back to S3, now you can just go and delete this file system. And your data is just fine living in S3. And then the next day, you can just make a new Lustre file system, and just that will import your data, and you can just reuse it, and it'll just all be the same, including permissions and everything. So that's a pretty neat feature. So with that done, that's really all I wanted to talk about in this first section of like how to really get started and how to create a workstation and hook it up to a Lustre and just start playing around. Of course, there was a lot of manual things that I did here, like manually exporting the data and manually creating the file system. In the part after part 3, after the next part, I'm going to talk a little bit about automating those kind of tasks. But maybe before we jump into the next demo, is any questions that we should? I'm just going to switch over to that. What version of Linux is being used in this example? How can you change the version of Linux? So if you use the Teradici AMI, of course, you basically get what they give you, meaning their image is usually based on a CentOS 7.8. So they're staying pretty up to date. They update them very frequently, so you're always on a very recent version of CentOS, but they probably will stick to CentOS because that is just in the visual effects world. I wouldn't recommend trying anything else but CentOS. But you're free to, as I mentioned earlier, you can also buy your own Teradici cloud licenses and then build your own machine from scratch, where you would just start with a regular CentOS AMI, which gives you a very minimal Linux with essentially nothing on it. So you have to install the desktop environment, you have to install a driver. So it's a bit more involved, of course, but you have the freedom to build whichever workstation. If you wanted to build it on CentOS 8, I wouldn't recommend it because a lot of applications won't work with it, but you certainly have the freedom to do so. I think everything else looks answered. So in that case, I'm going to jump to the next part of the demo. So in this part, I will close these tabs up here, and I'm going to actually switch to a different account. So I'm going to demo, so I'm going to go to demo 2. So this is an entirely different AWS account, which is also a neat feature about AWS. You can actually have a whole organization holding multiple accounts. So you can really separate your projects out nicely, which gives you can make an account for development, you can make an account for production, you could make an account for an individual project if that's necessary. And if you work on, say, a Marvel show and they ask you need to separate your project, you can certainly create a separate account. So what we have here, you can see also a workstation here, but here actually have an 8 extra large. And if we look again at our instance types here, an 8 extra large, the reason I chose it because it gives you a full 50 gigabit of network connection. And we want to look at the Lustre performance and how much data we can actually push through it. We'll see if we can actually hit 50 gigabit of throughput, which would be about 7 gigabyte per second, I suppose. And also have a deadline server here running, because we're going to look at rendering using deadline and spot fleets as well. And if I just jump over to my FSX console here, you can see I also have a Lustre here. It's quite a bit larger than the other one, so it's 36 terabytes large, which gives you 7 gigabyte per second of throughput. So that is the equivalent of 50 gigabit. So that's why I chose this size, to basically match the throughput size of my instance. And with that said, let's just jump into that workstation. So here's my demo 2 workstation. So you can see this workstation. This is actually one that I built from scratch. So this one I built from CentOS, from a base image, and I just built a custom image because I actually have licenses for Terra-D3 that I bought directly from them. So I'm using those rather than the AMI they offer on the marketplace. And I have a couple of windows open already. So this one is just an image that measures the network throughput. So here you can see what we're actually doing. And on this side, I just have a command. You don't need to really know what it does, but essentially it just drops all the caches on the OS level. So once we play an image sequence once, there will be some local caches. So to actually see what's happening, we want to be able to drop that cache. So let's just get into Nuke here. And I'm just going to load in. I've got a 4K image sequence here, which is fairly long. It's 500 frames long. And this is full res 4K zip-S compressed. So it's not it's a production worthy compression format, I guess. And we're just going to go first and play this through a flipbook, because the flipbook reads files a little differently than Nuke does, of course. The flipbook reads it more efficiently for playback, whereas Nuke reads it more efficiently for compositing. So we're going to look at how that looks. So I'm going to click OK here, and it's going to start playing, and hopefully it plays real time for OK. It should. And I want you to just keep an eye on this number here, the current incoming traffic, and we'll see what we get here. So you can see we get easily real-time playback. It's actually caching way ahead, and we're pulling stuff in at about 10 gigabit per second. So that's pretty good. It's not quite the 50 gigabit that the actual instance can do, but with having such high throughput, the bottleneck really becomes not the network, but more like your machine and your CPUs and how many read threads you have and what software you use and how efficient that is with transferring data. So after that, I'm just going to flush the cache here. And I'm also going to make sure that we don't have any cache in Nuke, of course. So now we're back to no caches at all. And if I play this in Nuke, you can see, Okay, there we go. So you see, we don't get real-time playback just because the way Nuke reads data, but it's just more efficient for compositing. But you can see we're still getting almost a gigabit of speed here, and playing 4K footage at like 5 frames a second isn't that bad over the network. And you can see we can even turn full frame processing, make sure we're actually looking at everything. It's very responsive with 4K footage. But we still haven't seen, obviously, the 50 gigabits. So let's see if we can do this some other way. So I'm just going to go out of here again. And I've actually written a little file here, this performance.sh. All this does, it copies, it's set to copy 32 gigabytes of data to the Lustre. So in this case, I want you to look at this outgoing number, the current outgoing, and see what that gives us. So I'm just going to launch this, and you can keep your eye on the number. And there we get actually 47 gigabit per second. And it's done. So that's writing 32 gigabytes of data to the network attached storage in 5 seconds. So we clearly have, like this, the Lustre clearly has high performance, and I haven't really found a piece of software that can utilize it all. The only way I found it is to have a multi-threaded copy process to the file system, and that just maxes everything out. So that is performance of Lustre. You can quit out of that. Just going to jump over to the questions, maybe if there's anything new. How do you log different users into workstations so you can integrate user info into pipelines? Good question. I spent a lot of time struggling with that too, because there's so many options, and I am not a systems manager as such. But there's several routes you could go. There is a route AWS offers. What's it called? A Microsoft Active Directory. So you could use that. What I ended up using, because I find it makes a lot of tasks really easy, is a service called Jump Cloud, which basically means you install a local agent on your computer, and then you can manage your user base, including Linux groups and everything in that Jump Cloud console. And it makes user management really, really easy. I think that's something that will probably change. Like that's one thing I hope will change with cloud workflows, where user management catches up to the technology, because something like Microsoft AD is pretty ancient in terms of technology, I guess, but it's still needed by a lot of applications, and it's sometimes the only thing they accept. And how to go about offloading files stored on the AWS over to a RAID or external drive plugged into your machine. So good question. In principle, it's a good thing that that's not very straightforward. And what I mean by that is, if you want to work on any production, and I had a few phone calls about where people ask, like, well, what's the security like, and with like remote people, and can they download footage? That's always the question. Do they have access to the actual data? And the answer, really, the simple answer is no, and that's a good thing. Of course, you can write tools to get data out. Like you have a Linux here, so you can install Aspera. You can utilize any file transfer tool that you want to use. I've used a Canadian company actually called Massive, which is really good because they actually offer a pay-as-you-go. So if you're looking for high-speed production quality and secure data transfer, I highly recommend you check out massive.io. I think they're a Ontario-based company, and they've been really good to me. With that said, let's move on to rendering. So I'm just going to jump over and open a fresh Nuke here. And I've created a very simple script here, because this is really not a webinar about how to composite. It is just more technical one. So I just threw a focus node on here with some noise to have something to render, I guess. And with that, I'm just gonna submit this to deadline. And I'm gonna talk a bit about deadline once I submitted it. I just want to get this essentially on the farm. So you can see we have 500 frames of 4K footage, and I'm just going to go 10 frames per task, meaning we will have 50 tasks. And you can see here on the group, it's submitted to a group called Spot Nuke. And this is essentially what tells Deadline that you want to use Spot instances to render this. And this is something you have to set up. You can call this anything. In my case, I call it Spot Nuke, but this is just something to tell Deadline that. We're just going to submit this. And I'm going to open up the monitor here. How are we doing on time, Matt, actually? Are we still good?
We're looking pretty good. We're at almost at 1 hour, but I think we're
already. Okay. I'm going to try and speed up a bit.
Yeah.
So you see, we get the job submitted and it's queued now, but we don't have any workers down here because it's basically just provisioning those in the background right now.
There's a question about how do you restrict freelancers and folks to come in, whether it's based on IP address, and I imagine there's different options with AWS accounts and IAM. Bernie, maybe you can talk a little bit about what you think some of the good approaches are.
To restrict access? So you can like
workstations.
Right. So you saw when we created that workstation that I put in my IP as the only IP address you can connect to it. So you basically do it via security groups. So in a production environment, the way I do it is every workstation gets its own security group, and that only allows any traffic from the IP address of that artist. And because a lot of artists are behind a residential internet connection, that IP might change. So I've added some automation where people can, and I'm going to show you actually kind of how it works. They can essentially change their IP from shotgun and make sure they stay connected. But just jumping back here, like you can see the renders have picked up now. So that took about, we submitted at 18:55:41 and it picked up at 18:57. So a minute and a half to launch us 50 render nodes at once here. So that is pretty good. And we can see they're chugging through the frames here. And the cool thing is, once this is done, and these workers are all idling, they will shut down automatically again. So in my case, I've set this to 1 minute. So if they're idling for 1 minute, they will just shut themselves down and you stop paying. So in this case, I paid for 50 workers, but I'm only paying for them for really, it's such a simple script, so I'm only paying for like a minute. But we'll see these guys shut down when they're idling for more than 1 minute. So if we just jump back to our EC2 console here, I'm going to refresh it. There should be a lot more now. So we can see there's a lot more instances now. They're all running. But if we just wait a few more seconds here, we should start seeing them shut down. Now they're all just half a minute. So they're just coming up to that full minute of being idle. And of course, you know, and depending on your environment, you can set this to 10 minutes. That may make more sense. So you don't have to always take that 2-minute startup hit. If you know you're going to have more renders coming in, you can always set them to maybe hang around for a little longer, just in case another job comes in, so they can pick it up right away. So you see the first one hit a minute here. So if we jump back to our console here, there we can they're all shutting down again.
There's the question around having freelancers come in. We also had a component about how do you handle artists who might have different IPs each day based on dynamic IPs. Is there a way of setting up login-based access to workstations?
Well, you always have the login based, so you always have to authenticate with your username and password, of course. But considering that, I guess best practice, you want to have at least some sort of second factor that needs to be met. So if a user's password gets stolen, you don't want anybody to just be able to log in. So you want to have that IP added. Like that's what I'm using as sort of my second factor, is to make sure I'm only allowing from that specific IP address. And in order to do that, there's some automation, and I'm going to get to this. Actually, just now we're going to move on to the last part of the presentation. I'm going to talk a bit about automation. And yes, the way it works is if you have, like whenever you log into Shotgun, this is where artists will control their workstations. And that's where things are actually being set on the fly. So let me just jump back here to the presentation to kind of show you how that works. So I want to talk about two more things, and hopefully we have time for all of it. But there is, I want to talk about multi-region or like a global architecture, how you can have a global studio. And in the next slide, I want to talk a bit about what's called event-driven architecture. So in a global architecture, the way I have set it up is you have a user. That user can be anywhere in the world pretty much. And that user logs into Shotgun. And from Shotgun, you have the option to basically control your AWS environment for that specific user. And that's done via action menu items. And what those are, if you are not familiar, I can show you here. Here's my Shotgun page. What those are, and you probably use them all the time in whichever studio you work, they're just these like right-click context menu actions. So you can see I have my cloud workstation, and each artist has the option to, they can start the workstation, they can stop them, they can reboot them, because sometimes they crash. Like you can't actually, and I'm sure if you have worked in a remote environment before, something crashes and you have to call IT in the data center, got to reboot my machine. So you can actually do this from here easy. And then here is also the update my IP. So if your IP has changed, you can update it here on the fly. So that's how users connect to the AWS environment. And that request essentially goes to Route 53, which is AWS's DNS management service, if that's the right term. Yeah, so a bunch of AWS people on the chat, so hopefully I'm using the right terms here. And Route 53 then figures out, based on latency, where to route you to. So it goes out and goes like, okay, if you are in Vancouver, I'll route you to US West 2, probably, which is Oregon. If you're in New York, you'll probably be routed to US East 1. And if you're in, this happens to be Frankfurt, so if you're anywhere in Europe, it would route you to Europe. And it hits an API gateway there. And I'm going to talk about that in the next slide a little bit, what's happening within the region. The cool thing about this is if anything goes wrong anywhere, so if your Oregon region goes down for whichever reason, this could be an admin setting something wrong, or maybe it's a natural disaster, who knows? But it's down. Route 53 can actually constantly check each region, and if it determines US West is down, it will just stop using this route. And then if somebody from Vancouver logs in, they will just be rerouted to US East 1, which is more latency, of course, and not ideal, but at least you can keep working. So that's a pretty cool feature with that. And the reason why this works seamlessly is kind of twofold. So one is that all data is constantly being replicated between these regions. So as something in Oregon is being published, that's being pushed over to the other regions. So if you have one artist in Vancouver and the other artist in New York, that publish will be replicated immediately, and that artist can then use them. And the other thing is that the way I've set it up, at least, is the home directory is a sync to a global bucket. So if the user is in Vancouver and logs in, that home directory is synced to the S3 bucket, which means if that user maybe goes for a vacation to the UK and has a workstation there as well, you can log in and you will have essentially the same experience because your home directory is the same and your network data is the same as well. So that's kind of the way I have set up multi-region or global architecture. And the next thing I just briefly want to talk about is event-driven architecture. And that's really where I think cloud workflows can become really powerful and really efficient in terms of cost. So first I want to mention a term called AWS CloudFormation. What that essentially is you've seen me set up, in the first part of the demo, you've seen me set up everything manually. Like I've set up the workstation and the Lustre and the bucket. So what CloudFormation is infrastructure as code, meaning the entire infrastructure is coded just as you would code a application, meaning you can update it, you can roll back, you can easily deploy this infrastructure to multiple accounts, multiple regions. So that's when you do multi-region deployments. it makes sure that all your regions are set up correctly, so there's no room for error. And it also helps because your infrastructure is within CloudFormation stacks. It means that automation tasks don't have to set up every single piece of infrastructure. They could just call a CloudFormation stack. So if the automation wants to set up a FSX file system, it calls this stack and it does everything it needs to do in order to set it up. So everything within the region is set up using CloudFormation essentially. And here's a little icon we saw in the other slides. So this is how users can communicate with this region, which is an API gateway. And that is backed by a Lambda function, which is a serverless function, which uses Amazon DynamoDB to store all the data, because this is obviously stateless and serverless. It can't hold information between being invoked. It just uses this to store the data. And then really Lambda is responsible for taking care of everything within the region. So it is responsible for setting up your FSX. It's responsible for starting your workstations. It's responsible for setting up your deadline server and all those things. And then of course, deadline in turn is responsible for your spot fleets. So this is sort of what I mean with event-driven architecture, is that you're not letting things hang around here and just cost you money and have workstations run 24/7, but everything is more on demand. And this scheduler can, of course, run with user-initiated calls. So it can be like, oh, a user wants to request a workstation, so I'm going to start it up. But it can also be on a schedule. So you can say, at 8 in the morning, I want to spin up my Lustre because it takes 10 minutes. So I want to do that before everybody comes into the studio. And in turn, it's also responsible for decommissioning everything, say, at the end of the day. So at the end of the day, if there's no more rendering going on and everybody is locked out of the workstations, you're really just paying for a server, and especially the Lustre. And Lustre isn't necessarily cheap if it's very large. So it can go, and in my case, I have it set up so you can give it a timer, which is an idle timer. So let's say we say an hour. And my region has been idle for an hour, then Lambda is going to go, okay, I'm going to go ahead and shut down my deadline server. I'm going to back up my FSX to my S3 bucket. And once that is done, I will decommission my FSX. And then overnight, here's essentially what you're looking at in an idle state, which is, for the most part, all of it is really serverless and free if it's not used, with the exception, of course, of the Amazon S3 storage. But it is the lowest cost and most durable storage. So you need to store your data somehow, so you need to pay for that, I guess. And that is all I wanted to talk about in this webinar. So I know I went a little bit over. I apologize for that. I just wanted to throw up my email here. If you have any questions, if you want help, or if you're interested in exploring more what you could do with your studio, or maybe as a freelancer even, feel free to shoot me an email, and I'll be happy to help. So with that said, thanks everybody for watching, and I'm gonna just send it over back to Matt. Do you wanna?
Yeah, that was excellent, and I'm especially pleased to see all the really great questions. They're all really deep and interesting. What a great crowd! What an awesome webinar! So thank you, everyone. And Bernhard, I think this has been really great and hopefully very helpful to everyone. So thanks everyone for attending, and be sure to watch the on-demand version and go over it with a fine-tooth comb if you want to get into the details, and don't hesitate to reach out to Bernhard and if you have more questions. So thanks very much, everyone.
Cool, yeah, thanks everybody.